We are going to present to you the MoVA specific enabler, and just a couple of words, because probably most of you don't know our company. We are officially a textile research institute, and in textile there's a long tradition to look for clusters, to look for networks, to find the best actors to set up the most efficient network in producing things, because textile is a multi-stage production thing. And apparently this networking approach is becoming more and more usable also in other sectors. And within the FITMAN project, we had a huge trial with TANet in the automotive sector, where we were setting up clusters of small companies in the automotive sector that would be able to respond best to a public tender or to a private tender, where we say, okay, we need a certain amount of products in a certain time, and then the cluster manager would need to set up the perfect network for that. This is just to tell you a little bit what we're gonna do. Actually, it's not only me. I will do the introduction, and then I will pass over to Konrad, who is going to show you the technical details, how to get MoVA, how to implement MoVA, how to install MoVA, and then I will take over again and explain you the use case. Getting MoVA means that you get our own open source software, which we developed here since within the last 10 years, I think. The official open source software is Rediscover, and it's a server application. The only thing you need is Apache Web Server, PHP, and a MySQL database. So this is the technical prerequisites. It's rather simple, and my colleague Konrad is going to show you now how you get MoVA and how do you install MoVA, and after that I'm back with the explanation of the use case.
Thanks, Thomas, for introduction, and I will show you now how to get MoVA. You get MoVA, you find MoVA in the catalog of FITMAN, clicking on specific enablers. You get all the specific enablers, and there you also can find MoVA. And there's also a short documentation. And if you click on downloads, you find on the one side you find VirtualBox, and on the other side you also get the code. We now clicking on getting the code via SearchForge. Clicking on files, you find 3 files. README is just for listing here the documentation, and you can download the demo and the Rediscover source. Now we will do this. I have to do another click. Save for the software, clicking on the demo, for downloading the demo. Also saving. Now we have in our download folder, we have 3. I downloaded it twice. Have 2 files: the Rediscover source, the MoVA source, and the demo. As it takes some time, I have already unpackaged the zip file this morning. This is this one. To install it, we are using the XAMPP installation for Windows to run it, which includes Apache, PHP, and MySQL, and the web server folder to place the files to run. What's happening? Okay, is placed in the folder C, XAMPP, htdocs, and I copy the files over there now. What's happening? Sorry, my Windows is hanging. Okay, here we go. Place here. I move it over, and now as we have placed it in the webhook, we can call it using localhost, and the folder name is MoVA. And as you see, you have a web application here. First of all, we have to import the demo repository to run MoVA. We log into the repository manager with a standard password. In a production system, you should change the password using the change password functionality with after the first login. We don't do this at the moment because we have no production system here, only a test system. And now we restore the repository from a backup file. We are using the demo repository. We open it from the download folder. And now we select the demo repository, clicking next, providing the MySQL database information. We test the connection. As it is successful, we click on next. We give a name. And now we give a location name, which means the database name, and also the file system folder name where the repository is placed later. We also test if the location is unique, clicking next. We have to select the code version, as you can run more than one code version in the system. And now we click on Restore Repository, and hopefully this will work. Okay, clicking on the MoVA demo, we could start working with the repository now. I will show now first using the Oracle VirtualBox, which is exactly the same, but you have to need no web server for it. You can have a packaged system. Therefore, we also import the application from the download folder, open it, clicking on next, import it. Takes a few seconds. Okay. Okay, ready. And now we start the machine. Starting up. We have to start the machine only one time. Not only we have to start it always using the system, but we haven't to log in each time. But the first time we have to log in to look for the IP address we got from the DHCP server. And now we get no IP address. That's not good. Okay, as we switch to network now, we get no IP address. Normally, you would get a, if you are connected to the DHCP server, you will get an IP address and you can look it up and then call the browser using the IP address. And the virtual machine also includes the test demo repository, so that you haven't to import it. Okay, as we get no IP address now, I will switch up over to Thomas again. Presentation or
browser.
Browser? Okay, you using the browser.
Okay, now we will log into MoVA. We have a little demo system running. You get the password in the documentation, so don't worry. And what did we do? What is MoVA? MoVA is basically a semantic enhanced information object type of database. So what we can basically do is we can create a number of object types, and these object types represent, for example, the assets. And then we can also, and this is the difference to a database, we can design a number of relations between these assets. And I will show you first the result, basically, and then we can go step by step in what is behind these things. For example, the use case would be that the network manager finds a new requirement. A new requirement would be somebody needs exhaust systems for a certain type of car. This is the target would be that we need 2,000 exhaust systems at a certain price. And now the network manager has the challenge to find out of a huge number of possible suppliers and small companies that can contribute to these exhaust systems, that he finds the best matching network. And in order to find the best matching network, he can define certain criteria. And the criteria, we try to keep them really simple. We say quality, capacity, and cost. So there are three areas of focus. Either we are looking for a really cheap product in the end because there's a very competitive price, then the cost within the suppliers needs to be low, or it needs to be quick, delivered quick, so we need a high capacity, or it needs to be a premium thing, so we need a really high quality. And of course, all the network managers and all the customers want all of them, but they have to add up to 100%. So you cannot ask for more. You cannot ask for highest quality, highest capacity, and flexibility, and lowest cost. This is not possible. So you have to set your preferences here, as I did here. And if you don't like these ones, you can change them. So you can say also here 20 and 50, for example. So here you already see the basic idea of this web thing. So we have here the main tab. This is the requirements. Here we have the requirements. The current one is the exhaust system for XYZ. This is actually the only one. If you would want to, normally they are imported, of course, from tender sites, but if we want to create one manually here, we could do this by setting a new object. But here, first of all, let's go for this one. And now the magic button here is to find the cluster. So now the system is looking who can do exhaust systems, who can contribute to exhaust systems, and who fits perfectly to this quality, capacity, cost thing. I hope this works now. And here we see the result, and we sorted it by different levels. So the first level is we find somebody who is doing a full exhaust system. This is, we call it exhaust station 1. They can do really exhaust systems. They don't need any additional partners. And they match to 90%. They match to 90% because they are really good in capacity, they're really good in cost, they are medium in quality. So this is the evaluation of the supplier, and this one fits more or less good to our query. There's another exhaust system that is only fitting 50-50, 55%, because they are capacity not so good, cost really good, and quality rather poor. Of course, this is all sample data. But now, there might be the system manager that says, no, I don't want to have exhaust system 1 or 2 because they are not flexible enough, they are not quick enough, whatever. I want to have a network of partners. And then we know an exhaust system requires a pipe, it requires a catalytic converter, it requires welding activities, it requires brackets, and it requires some sort of project or time management to bring these partners together. And now our system looks for partners that are able to do the piping, that are able to do the catalytic thing, that are able to perform welding. Here we have 2 ones that are able to deliver the brackets and that are able to do time management. So step by step we have a decomposition of the exhaust system into its activities and parts that are required, and our system looks for the best fitting companies in order to fulfill these requirements. We can go even one level deeper, and then we realize that there's nothing because we don't have partners that are able to respond to catalyst and mounting, which would sum up to a catalytic converter, and the catalytic converter again goes into the exhaust system. So this is just a demo system with only few data in there, but you see already how it works. And now let's look what we did in order to achieve this. In order to achieve this, we need to model everything. And here you can see we modeled, for example, the assets. That means these are the companies that are able to contribute, that are partner of the network, the ones that we need to find the best fitting ones. Here you see, for example, exhaust station 1. We can click on exhaust station 1. This is a big supplier, part of a big supplier. And here you see the evaluation of the exhaust station 1 according to the ranking of the network manager. So this is the implicit knowledge of the network manager, how he ranks this supplier within his network. And this is important if you have 200 or 300 suppliers, then you can rank them or you can evaluate them according to your subjective opinion. And if you really look then for the best fitting network, then this your personal opinion is reflected in the search. So exhaust station 1, what do? They are linked to a domain entity. This is an abstract word, a domain entity exhaust system. That means they can do exhaust systems. If we go back to the list of the assets, we see, for example, another one, pipeline. Pipeline are part of the company Cats and Pipes, and they can do pipes. So this is mentioned here in the domain entity, they can do pipes. And now this is a fully supporting front end that is offering fully hyperlinking. So if we want to learn more now about this domain entity pipe, we can click on pipe. And we see pipe is part of exhaust system. And this is basically the magic behind it, that we created a domain ontology. We created a hierarchy of subjects or of technical things that are part of the next one. So we can basically deconstruct an exhaust system into, if we click now on exhaust system, you see that an exhaust system consists of time management, of bracket, of catalytic converter, of welding, and of pipes. And this is the specificity, this is the importance basically, So the project management is not so important because it's a general thing, but the pipe is really specific for an exhaust system. That's why it has here a higher number. And all these numbers are then used in order to find the best fitting network. And if we want, for example, to modify something, we always have the chance to click on the edit button, and you can see here we can, for example, kick out the time management when we say we don't need this anymore. They can organize themselves. We could kick it out, and then it's gone. And then we click on OK, and then we have only 4 things that are required to build an exhaust system. And if we now go back to the requirement and find the best fitting cluster, then you see that here the time management is not needed anymore, and that the company who would provide this competence is also not found anymore. So this is basically the thing. You can manage your domain ontology, you can say what you need, and you can say what the companies can do, and these information is used to find the best fitting networks. Okay, just to continue with the few slides that you will find as a handout. So this is what I already explained, and this is again the data model of our demonstrator. So we have the suppliers, we have the assets, we have the domain entity that forms the hierarchy or the domain ontology, and of course we have the requirements linked to these domain entities. So we say we need exhaust systems. Okay, the linking word is the exhaust system, and then we know who can provide exhaust systems. This is a bit about the detail on the ontology. So we have parts and work, and we have the numbers that are representing the significance. And this is, for example, our ontology model again. We have the exhaust system consisting of time management, which we just canceled, catalytic converter, pipe, welding, bracket, and then again catalytic converter can be subdivided in catalyst and mounting. The suppliers and assets, as I already mentioned, are evaluated in terms of cost, quality, and capacity, and the requirement is also specified in terms of quality, cost, and capacity, and this means we find the best fitting ones. And that's basically the end of the presentation, and we